Hello and welcome to this AIM webinar, Engineering RFID Success, How to Choose the Right Antenna for Your Use Case, presented by our speakers, Mike Crudell and Brendan Davis from Arcadian Antenna. I'm Bethany Dean, the Media and Communications Manager here at AIM. And before we get started, I wanted to first give a brief overview of AIM. So AIM is the Industry Association for Automatic Identification and Data Capture Technologies. We serve as a trusted platform for quality resources covering all types of barcode, RFID, and mobile computing information. We also foster new auto ID innovations that stimulate market growth. We encourage you to get involved. If you would like additional information, you can reach out to us at info@aimglobal.org. And then a quick review of AIM's antitrust policy. It is the policy of AIM to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. And then just a few other housekeeping notes. All registrants are muted upon entering the webinar, but we still want you to participate. To send a question, you can select the Q&A icon at the bottom of the screen. We'll have some breaks in between the session for you guys to ask your questions, and then we'll get to as many as the questions as well at the end of the presentation. Also, a recording of the webinar will be available in the coming days to those that have registered and be accessible on our YouTube channel. And with that, I would like to turn it over to you, Brendan.
Hey guys, I'm going to go ahead and share my screen here. First and foremost, I want to thank you all for joining us. We really do appreciate it. Really, the purpose of this webinar is how do we ensure that we are choosing the right antenna for your needs? We come at that with quite a bit of experience over here at Arcadian. So with that, I want to introduce our speakers, myself and Mike Crudell.
Good morning, everybody. My name is Mike Crudell. You want to just go to the next slide there, Brendan? That's me there. Founded Arcadian 25 years ago. We are a wholesale distributor of RFID hardware. I want to be clear, we're talking specifically about antennas, mounting solutions, and cabling. But I was involved with the Walmart initiative 20 years ago. So I've been around RFID a long time, helped a lot of RFID system integrators with scoping antennas over the years, and we're going to get into that a little bit today. Without further ado, I'm going to introduce my colleague, Brendan Davis, from our RFID business development team.
Hi guys. So I've been in the industry for about 10 years. I've worked at partners, manufacturers, and most recently a distribution partner. Really what that's given me is kind of a perspective that helps me to see how our clients and partners operate within this ecosystem of our channel and try to remove as much complication as possible. So again, I've worked in the IDC throughout my career. I've seen a lot of companies move from pen and paper to barcoding, and finally RFID technology seems to really be taking off. So again, gives me kind of a unique perspective, and looking forward to speaking with all of you and teaching a bit about what we do and how we can help.
So just a little overview of Arcadian, who we are and what we do. So we focus completely on antennas and antenna-related accessories. We've got a couple different groups within our business that do different types of antennas. Obviously, what we're going to focus on today is the area where of my expertise, which is RFID. Very passionate about RFID. I want to be clear that we do not sell to users. We sell to OEMs, and we sell to RFID system integrators such as yourself. So we are a wholesale stocking distributor, somewhat along the lines of a Blue Star or a ScanSource. We stock antennas, mounting hardware, dock door portals, coax cable, etc. But we're much more than just a stocking distributor that moves boxes. We are RFID antenna experts, and we pride ourselves on helping our system integration partners win deals by assisting them when they are scoping in hardware. And we help them choose antennas that maximize system performance, minimize cost, and then as a distributor, we ensure that the stock is on the shelf so that you've got the product that you need when you need it, whether that's for proof of concept or for full project deployment. So what is it that we sell? As I mentioned, obviously antennas and accessories, but what brands? Some of you may know these brands. Our largest brand that we represent by far as a distributor is Time7. Time7 is a New Zealand-based company that makes low-profile, slim RFID antennas. We also represent New Wave. New Wave is the antenna elements that you would find in an SLS type portal. We have RF Max, which is our in-house brand of antennas. These are typically what we call air dielectric antennas, both far field and near field antennas, as well as mounting solutions and cabling. We are proud to announce that we are bringing on the Keon brand of RFID antennas. That distribution agreement was signed last month, and we anticipate that our stocking package will be on the shelf in May. We also have MTI Wireless Edge, which is an Israeli-based company, primarily in the IP67, 68 outdoor antenna space. And then on the bottom, you're going to see this little TE Connectivity logo. TE Connectivity, formerly known as Laird Technologies. We got this logo pretty small because it seems as though they are de-emphasizing their RFID offering last couple of years. So typically don't recommend them for new designs.
So, guys, this is really the objectives of the webinar. What we'd like you to take away from it, right? Why antenna selection matters, how to align that antenna to the application, avoiding common mistakes, and partner selection, proper planning, how to drive better outcomes within your systems that you're designing and implementing within your partners. Something we want to kind of touch on, right, is at the beginning of RFID, X amount of years ago, there was only a few antennas that we really had the option to go with. It was, a handful of antennas that we had to use and try to figure out how to make work. As RFIDs evolved, what we've really seen is a switch from general purpose to application specific. As you can see, there's quite a few technologies, there's quite a few form factors that we've listed out here, but that's something that we really do want to stress, right, is that we are now in a world of RFID where we can actually choose an antenna that's really designed for the specific application rather than pick amongst, 5 to 6 antennas that used to only be available to try to make those work to the best of our ability. So, guys, really what this objective is RFID antenna selection is really critical, and how well your system performs in the real world. If you choose the wrong antenna, your application can lead to inconsistent reads, operational inefficiencies, unnecessary costs. So we're going to take a really high level practical approach to understanding the applications that require these different antennas. So if that's tracking assets, managing inventory, workflow visibility, it's important to choose the right antenna to ensure your system performs reliably and it's giving you guys and your partners and clients the results that they're expecting. We're also going to discuss how choosing the right partner with that expertise can simplify that process, helps you make informed decisions and improve your performance, reduce trial and error, and support you guys long term. So to get started, there's 3 different technologies that typically encompass RFID, and that's really based on the read zone. There's give and takes to each, but wanted to quickly kind of run through these, right? The vast majority of RFID deployments and hardware in the market is what we call far field. That's going to give you a broader coverage, increased range. We typically see in ideal conditions, tags can be read up to 30 feet, and this is ideal for, asset tracking, inventory tracking, dock doors, movement within the aisles of your warehouse. So that covers the most area. The next step down is mid-range, which is a controlled zone read. We typically see tags read between 5 and 10 feet based on, the environment and how we tune that antenna. So shelving, personnel doors, conveyor tunnels, really anything where you're looking to control the read, minimize stray reads, but not have something that needs to be extremely close to the tag you're reading. And lastly is near field antennas. Right, what those are, it's a very tight and precise controlled read zone. We typically see tags read between 1 inches to 15 inches. This is ideal in, receiving stations, packing stations, checking in and out of assets, things of that nature. And really the benefit of these is minimizing cross reads. So guys, just before we move on, want to check in. Does anyone have any questions on these 3 technologies, how they operate, the differences between them?
By the way, so we're going to have questions at the end, but this would be a good time. If there's any questions specifically about antennas, how they work, gain, beam width, circular, linear, multilinear. I do see one question in the chat. Unique challenges in the medical space. I think we'll push that to the end. Anybody have any questions, antenna technology questions before we move on in terms of, here we say, when you say near field, do you mean specifically near field coupling? So Chris Brown, thank you. So yes, we do. In general, there is 2 different types of RFID antennas. The far field and mid-range antennas are doing radiative coupling. That's basically an RF signal that is transmitting energy to an RFID tag, exciting the tag. The tag reflects back the serial number to the antenna and then onto the reader. So the physics is that is you are using RF radiation to read the tag. Specifically, when we're talking about the near field antennas in this presentation, these are inductive coupling or magnetic coupling. So that's why this is the near field antennas we're talking about are either tap and go, where you literally got to touch the antenna with the tag, or where you're trying to read up to maybe 12 or 15 inches maximum away from the antenna. We've got another question here on antennas. We'll push this one to the end. Very clear for now. After shelves, borders, shelves. I think everything else we can push to the end. All right, so I think we're good to move on. Oh, let me just ask here, Chris Brown, following up, can you get 15 inches with inductive coupling? Seems far. So the answer is yes, I've seen it done, and it has to do with the size of a near field antenna. You can, if you use smaller near field antennas, typically it pushes more energy straight up and there's less loss to the sides. So yes, I've seen like a 1 foot by 2 foot antenna might be able to read 10 or 12 inches off the surface of the antenna. But if you take that same antenna design and get it down to 6 by 6 inches, you'll read 15 or 18 inches off the surface of the antenna. It can be done, and we could certainly talk about that, the specific models that would work best in that scenario. We can take that offline. So you can go ahead and proceed, Brendan.
Okay. So really what we want to stress is any RFID project in a warehouse has different read zones, different strategies. So we're going to typically require different antennas to address those problems. So we didn't want to really just lecture you and kind of give you, hey, this is how this technology works. This is how midfield operates. What we wanted to do was actually show you a real world use case for a rollout that we did and kind of walk you through step by step, right, of each. This particular project had a lot of different challenges, and we want to show you how we overcame those challenges at each of these stages within the warehouse. So we're going to walk you through each location, run you through the antennas we selected, why we did that, and then we'll discuss a bit about that technology, how it works, why it was applicable, and for each specific use case. So starting out, I just returned from Modex. I was in the booth with one of our primary portal partners. Portals have been around for quite some time. We've seen some great additions in the industry. This is actually using a multilinear technology. It creates a very well-defined read zone. And if you guys look at that picture on the left, you can actually see we've angled and canted those towards the dock door. What that's going to do is help us from reading the staging area, help us to have a better controlled read zone. Really what these are doing is it's reading only what passes through. And with the correct tuning, installation guides, and design, we can really mitigate that risk of cross reads going into the truck, any other systems that might be next door to it, just to focus on that particular shipping or receiving door. This is ideal for pallet and box level reads, whether that's incoming or receiving. There's a lot of different options too. It used to be that these were, there's one type of portal and we'd ship that out. We really like these. If you see in these pictures, these are modular antennas, right? We can build them out any way we want. We can single stack them, double stack them. There's a lot of accessories. We can do a radar on these also for directionality. If you don't have dedicated shipping and receiving doors, if you have one that receives and ships, we can track which way that pallet's going. We can have a photo eye to trigger these to actually turn on. We can have a camera that takes pictures or videos. So if you receive a pallet that's damaged, you can take a picture of it, send it back to the vendor, or you can also validate that, hey, we got all these RF reads. We also took a picture of the shipment at this time and it went out. And lastly, there's also a light stack. The best way I can describe that is a traffic light. It's an audible and visual cue for your forklift driver. Green means good. You're matching the manifest, so you can drive on through. Yellow means that, hey, we need to keep reading. The system's buffering, something of that nature. And lastly, red, right? We can have an audible chime. We can turn the light red and say, hey, something's missing on this manifest. This is not allowed to go through out to the truck. And it gives you that kind of last stopgap before you ship out something that might not be correct. So the trade-off, right, is excellent control, really tight, dedicated read zone, but it does need the right physical choke point to make this actually work well, and you do need experts to set it up. These are not feasible for back of house operations like cycle counting, anything like that. These are really dedicated to the dock doors.
So before we move on, I definitely, this is we see widespread use of dock door portals, and we do. I wanted to open it up to questions. So before we move on, I want to mention a couple things, then we'll see if we've got some questions here. So just to be clear, Brendan, you've got so traditional portals would have been one piece design, 6 or 8 feet tall. Tell us what's different about what we see here in this picture.
Yeah, absolutely. So guys, you know what? I'll use my mouse to point. If you look right here, these are two separate antenna elements, right? And they're modular. And when I say modular, what that means is that we can build these out really any way we see fit. We can ship them, palletize them. It's much easier to ship. They are very easy to put together. We have risers that we can put in place also should we need extra height. So something that we really like about these antennas is that modularity, right? We do not need to have a single 8 foot section that ships now. We can have two 4 foot sections if we need to further increase the height, put a riser between the two. So that's something we really like just from an installation perspective, from a shipping perspective, and just how easily it is to customize these solutions for our clients.
So I want to mention that riser section that Brendan spoke about. What we're talking about is a 10-foot section that you would either add underneath the first portal to raise it up off the ground. So you can save some money by instead of stacking two portals, if you've got pallets that are only 4 or 5 feet tall, typically, they're being carried by forklifts 4 or 5 inches off the ground. The pallet itself is 4 or 5 inches. So typically you don't need RF all the way to the floor. So you could add a 10-inch riser section on the floor to pick the first antenna up. And then you can add a second riser section in the middle. And within that riser, which doesn't have anything in it, it's just a spacer essentially, you can add a radar unit which detects directionality. So that was one of the questions that came up in the chat. Like, how do you determine directionality utilizing a portal? You can do it with software, but our vendor here literally has a new component, a radar-based component that would be physically added into the structure that would detect directionality and feed that information into your reader through the GPIO port. I think that's it, Brendan. We can move
Okay.
on to the next slide.
So, guys, this is, as you can see, a overhead solution. These are actually now we're seeing these be used more and more. It's a technology that's in development and ongoing, right? Some of these are brand new. We're seeing more and more of these vendors in the field having overhead solutions. If you look to your left, that is a Zebra ATR 7000. And if you look on top of that, that's actually something that we identified in the market as a whole, right? That is a 30-foot drop pole from the ceiling. The reason we actually put that in place and developed it alongside our manufacturing partners, as well as people in the current channel ecosystem, was not for lack of poles. It was actually for the lack of a pole that would put that system in place at the correct distance from the floor for ideal reads. Overhead visibility of shipping and receiving is now a really great option. It's great at pallet and carton level reads, but you can also kind of extrapolate that right into staging areas. This can extend beyond the dock doors. If you have these throughout your facility, you can further extrapolate that into the back of house. It's a seamless. So this is something that we're actually seeing quite a bit of right now, right? So dock doors are a great option, but we do see overhead systems. Again, it's not just this item here. We have quite a few vendors that have overhead solutions that we now see being used at dock doors. And with that visibility, again, it can reach into staging areas and even into the back of house in certain situations.
So I just want to clarify something, Brendan. So as a distributor, we carry a lot of things, but not this. So we're not a Zebra dealer. We leave that up to our RFID system integration partners. And this is a combination of reader and antenna. And I said earlier, we don't do readers. So we don't sell this ATR 7000 unit itself, but we sell the accessories that go with it, whether that's coaxial cable, Ethernet data cable, or mounting poles, as you see pictured here. All right, you can keep moving, Brendan.
So guys, this is a near field application, right, that we used in this scenario for package verification, check in, check out. As we said, right, this is a really controlled read zone created using a near field antenna. It's also actually two antennas in conjunction with it if you look above that near field antenna. But right down here on the desk is this near field antenna, right? And so what the goal was to verify what was coming in with a controlled read range in a very close proximity to all that racking that you see. So essentially what we were doing was passing packages through this read station and confirming the contents were correct, logging the contents, and then they'd be able to see that on that computer screen off to the left there. The verification, again, available on the screen, no risk of cross reads that would compromise the inventory verification. This is a great, great solution, especially if you need that controlled read range. If you look at how close they are to the warehouse, we're not going to pick up other tags, anything like that. It's strictly validating what was brought in that package. We also see Nearfield actually used in a lot of range of applications. We have clients reading, evidence, blood vials of these, check in or check out for assets of the company, tools, things of that nature. And they're even used in manufacturing, sometimes work in progress lines. And the reason for that is the tight constraints. You need a very close proximity to the antenna that's actually being read, but you don't have too much room to actually go ahead and install something larger. So the trade-off for this, right, is you're going to need more hardware. These antennas are not designed to be tuned to boost the range beyond what they're really designed to do. It's a strictly near-field application. That being said, it's far more precise, right? Whether you're tapping and going, check in, check out, or just validating what is inside a box that you place on it, the read zone is very constrained. And as a result of that, we can get very accurate reads and verifications out of this. So moving on to this is really kind of the crux of the issue that we were having. We had a lot of assets that we needed to keep track of. You will not see the antennas in this. They're actually housed behind the shelving, but this is a mid-range solution, right? This is for secure shelving, a very defined read zone. We have our RF Max mid-range antennas behind this that are typically rated for 3 to 6 feet. That's going to help us isolate, what's on the shelf. This creates a read zone that does not bleed out the door, right? So for this secure shelving area, the problem was is if you open the door and you have far fields, you're going to get bad data, cross reads outside. What we want to do with this mid-range is define that this antenna is belonging in this secure storage room and that this zone is isolated. That being said, we can get a lot more reading depth and visibility with mid-range because it's again rated 3 to 6 feet. We're only picking up what's in this room, and we can track these assets that need to be tracked as they enter or exit this area and allow for different types of applications or antennas to pick it up once they leave the room. So we combine this use case with other technologies, track the asset throughout the facility. But within this room, the mid-range gives us the opportunity and the ability to strictly have a dedicated reading zone that is not going to bleed over. We don't have to mitigate cross reads, and we can ensure that these assets are returned or that when they do get checked out, they're picked up by other antennas when they leave this area. So the trade-off on this, right, is this is not going to have the range of a standard range antenna. So more hardware is needed. This tuning is very critical in this. It has to be tuned correctly so that we're representing the exact area that we're trying to read in. And also, these mid-range antennas, right, we cannot tune them up to X amount of space. We need to have this controlled read zone. The last thing we want to do is open the door, start reading things out there and getting bad data that's saying, hey, those IT assets or these assets that your people are carrying around are now in the room. We need to define the zone and use the correct hardware to do so. So, guys, this is what we call standard or far field range, right? This is inventory, asset tracking in the warehouse, movement throughout the warehouse. I'm sure, as most of you know, far field antennas make up the lion's share of deployments across the board for RFID, right? So this is typically due to, the increased range, which gives us a reduced need for hardware. Tons of different ways that you can use these antennas to identify and track your assets. Really, for our application, we relied heavily on our standard range antennas in the back of house. When I say back of house, I mean away from shipping and receiving, not inside that dedicated mid-range zone. It's really movement throughout the aisles, staging areas, picking and putting away, things of that nature. So you can kind of see two unique instances. Again, over here we have a high gain antenna. This is one of our RF Max antennas. It's a 2 foot by 1 foot. Once again, using that 30-foot drop pole that we developed. That's really for tracking movement within the aisles. And if you look to the left, this is actually a smaller antenna that we used a custom solution on a forklift to mount to read while we were moving around these, right? So for these open areas, what we want to do is identify zones where there's heavy traffic, where the employees are moving around, where assets are moving throughout the warehouse, and where choke points really aren't an option. For a good example, if you look at a warehouse aisle, it doesn't really make sense to put portals at the end of the aisle. It's just cumbersome. We can achieve that just by using this drop pole and the 2 foot antenna with a high gain, right? So for the open areas, these types of antennas are ideal. Their ability to read over longer distances, the absolute vast amount of hardware and options we have to work with in relation to the gain, the DBI, what form factor, as well as just how easy it is to mount and adjust these antennas, make far field the best choice in this type of solution. So as you can see, we're using a 6x6 on that forklift with a custom mounting solution. We're using our 2x1 with our drop pole. Really what we rely on typically with these antennas is VESA mounts, drop poles, or some type of custom mounting solution where we have to think outside the box as we did on this forklift. So the trade-off with this, right, is that more reads means more potential cross reads. That extended range means that you're going to pick up more tags, but it's not always something that you're intending to pick up. So we really need experts in place to kind of define, hey, this is what we're looking for, and also to take into account what's going on in the environment around us. If you look at all this warehouse racking, I'm sure as most of you know, there's a couple of things that RFID just doesn't really get along with. Metal is one of them that can bounce or block the signal, liquids, sometimes carbon fiber. So again, you really do need an expert because there's so much standard range antennas in the market. It's critical that we choose the right one, whether that's range, gain, deciding if we need circular polarized versus linear. Again, we have that experience, that expertise to help you kind of guide you in the right direction as to what we think is the best option and then test in your environment. So we just ran through the three main technologies. I want to take a quick break. Does anyone have any questions about the antennas you saw, how those technologies were utilized in this warehouse? Questions of that nature about the pictures we showed you, the problems that we were solving, anything like that.
So yeah, even with these far field antennas specifically, usually we'll get questions about, well, what about linear antennas versus circular antennas, or beam width versus gain. So any questions like that, this would be the time to ask it. I'm just going to address the circular polarity question, which is, we sell at Arcadian a lot of different antennas for a lot of different applications, but in RFID, and by the way, they're all linear, except in the RFID space. In the RFID space, you can use linear antennas where the RF pattern moves only in one plane, one direction, or circular polarity, which is essentially a spinning of the RF signal. Now, why do we typically default to using circularly polarized antennas in RFID? The reason is because we typically cannot predetermine tag orientation. And in order to read an RFID tag with a linear antenna, both the antenna and the tag have to be in the same orientation. When you're using a circularly polarized antenna, which again just means that this RF signal is spinning, then you could pack a carton with t-shirts. Each of those t-shirts could be tagged, and you'll read every tag regardless of the orientation within the box. The downside is that you spend so much energy spinning the signal that you can't read very far. We typically say a far field antenna that is circularly polarized will read maybe up to 30 feet. By the way, this is using 900 megahertz RFID frequencies. However, a linearly polarized RFID antenna operating at 900 megahertz might read hundreds of feet, but not so with circular. So we see very minimal use of linear antennas in the RFID space. Brendan, I don't see any other questions right now when it comes to far field antennas, so I'm going to say just keep moving.
Okay, so guys, really the last point that we hit on this is loss prevention. And what we see in these are typically very mixed deployments. Anywhere else in this warehouse, whether that's the dedicated storage room, shipping and receiving, moving throughout the aisles, we have people that are participating in the process, right? That are actively trying to get those tags read or not trying to leave with one. In this situation, why you see these custom built solutions and quite a few different antennas used is this is really the last point, right, that we can read these before someone walks out the door with one of these assets. So on the far left, what you're looking at is a 10 by 10 patch antenna. It's giving us overhead coverage of really anything moving near the doorway. And then we get into a bit more customized solutions. So kind of want to run through each one of these. If you look at the center picture, right, what that is actually a freestanding arch kit that we provide. And that gives us the ability to create a choke point before an exit. If you look at that, you're actually going to see four multilinear portal antennas being used to try to pick up any tags. And just as another safety based on our testing and how tag orientation sometimes works, you actually will see at the bottom here, this is a mat antenna, right? Which is also trying to read that tag orientation. Again, if someone puts something in a backpack and walks out the door with it, sometimes multilinear will not pick it up based on the orientation of the tag. So we use additional antennas to try to ensure that we do. Also, the very far picture right on the right, that is an emergency exit. So if you look at that picture, we had to custom build this. And this is, again, that freestanding arch. You can see it's a half kit. We have ruggedized multilinear antennas on the right. If you look at the left, we also have less ruggedized multilinear antennas. We have a mat antenna on the ground. And then right up here, we have a 10 by 10 patch antenna, right? So this is kind of a good example of a worst case scenario. If we fail at the worst case scenario, right, that compromises the entire project. So we need to be able to make sure that these assets are read in the worst of circumstances. If we can make it work on the worst day, we can make it work on a good day. So this is just something that we wanted to bring up. There's quite a few different accessories used in these custom solutions, but it's simply the goal, right, is to catch the asset regardless of how that tag might be being carried out with an unwilling participant or the path that it takes through whatever opening it might be. And we do that by creating these choke points and custom solutions to ensure that however that tag is leaving, we have some type of visibility into it.
By the way, Brendan, I think it's a good point. Typically the people that are handling the product that is tagged, they are active and willing participants in the process. So they understand how to best handle the product or the carton or the pallet to get it read. And their goal is to get it read. In this case, we've also got a loss prevention element to this warehouse deployment where we realize that something nefarious may be going on where the employees may be trying to leave with those assets. So typically we don't have to come at a tag from every angle. As you see here, though, we are coming from overhead. That's an RFID antenna molded into a rubber mat, reading from the ground up. We've got portals on either side. So it does get complicated, which is going to lead me into the next, or lead Brendan into his next slide.
Yeah. Yeah, exactly. Thank you, Mike. So I think what it ultimately comes down to, guys, is these deployments can be extremely complicated, right? This, again, just looking at this, we have a ton of different elements being used. We have a specialty mounting up top of that patch antenna. We have our customizable arch kit that we can deploy. We've got reads coming from the bottom of the mat. We have two different types of portals. And I think that what we're trying to sum up is that as these deployments get more complicated, as you have situations like this with possible unwilling participants, it's really important to partner with people that have the experience and the expertise to kind of think outside the box and design these types of solutions using that correct hardware, right? We need to make sure the project's goals and requirements are met. And this is a good example of just how to make it work in the worst case scenario.
By the way,
So,
before we move on from this slide, I want to point out, so not only do we have heavy duty portals on the right, we have slim portals mounted against the wall. We've got a articulating bracket over the top with a far field antenna. If you look in the top right corner of that photo, what you see there, that's a passive infrared sensor. So that had to be custom made for this particular application because the far field antenna was reading into the warehouse, reading inventory that was tagged in the warehouse that was not walking out the door. So in order to eliminate the possibility of creating a potential security event and flagging someone for potential theft, we, our system integrator, put together this custom built passive infrared sensor so that the reader would only be triggered when someone was passing through the read zone. As soon as they passed through the read zone, it would shut the reader back off. The point being, sometimes you got to get really creative in these deployments to make it work the way you need it to.
Yeah, and that's where we really shine. And I want to stress that to our partners that we are experts in this field. We've been doing this since the first Walmart iteration. We test alongside our distributor or our partners as a value-added distributor will help design in these projects. Mike was on site to help design this one, and we really just want to make sure that even in these worst case scenarios, the project's a success, right? Because it only takes one failure point to start losing assets, and that compromises the viability of the project. So, um, as you've seen, there's strengths and weaknesses to each type of this technology, right? If it's standard range, near field, mid range, any of that, it's really important to understand and reach out to experts that can help you select that correct application specific antenna just to help mitigate any risks and also to take the most advantage of the hardware's potential, right? So, three things we want to just kind of warn you off on, make sure you want to avoid. These are just things that we see all the time in projects, so we wanted to bring them up. And the first is defaulting to far field antennas, right? As we've stated before, there used to only be a handful of antennas that you could use, right? And so people often just default to this, thinking this has the most range. And that's great. It covers more area. There's less needs of hardware, but that means that you're also reading more than you intended. So it's important to take a look at not straight out of the catalog, what are we looking at and how does it, what's the read range? What can we read? How far out? It's important to look at it from an application perspective of what's the best use case for this? What is the best hardware for this? And how do we take advantage of that unique properties of that antenna? Second one we want to bring up is relying too much on tuning and filtering over your hardware selection, right? So anyone that's worked with RFID, installed RFID knows you can get into that reader and start tuning the power and filtering and trying to make it read exactly the way you want. Selecting the right antenna can just minimize that. You don't have to tune, you don't have to filter anything out to necessarily prevent those stray reads, right? So it saves a lot of back and forth. It can make testing and deployments go so much easier, just making sure you choose the hardware that is best suited to the role rather than trying to, for lack of a better term, put a square peg in a round hole. And lastly, and I know Mike, you want to touch on this, but I'll quickly cover it, is ignoring the accessories, honestly. Failure to choose the correct accessories, whether that's mounting hardware, whether that's cabling. We cannot tell you how many times we've been on job sites and accessories are not brought up until the last possible instance. Those accessories should be addressed as soon as we start landing on antennas and use case scenarios and defined read zones, whether that's how you want to mount it, or even really small things like nuts and bolts. We've been on tons of sites where, we have an entire team there and now we're waiting around for 2 hours because we have to run to Home Depot and try to figure out, what's the correct bolt size? What's the correct nut size? Why wasn't this included? That's again a big labor cost and not having the correct mounting or the correct articulation of that antenna because of the mounting can really degrade system performance. So it's one of the last things people think about is the accessories, but it's actually very, very critical. And that's something we always try to address very early.
Yep. Now, to your point, Brendan, I mean, what we do often is, again, we provide nuts and bolts where they normally are not there. Those are the questions that, as a solutions architect or solutions engineer on your side, you need to be sure you're asking those questions because whether you're buying from us or whomever, it's, does the antenna include hardware? Meaning like nuts and bolts. Does it include its own mount or do I need to purchase that separately? How can I be sure that I'm getting the right and RF connectors for the antenna that I'm purchasing to mate with the reader or multiplexer that I'm going to be utilizing? We've got plenty of jobs that get held up in some cases for days. We've got guys waiting in hotels because they've got the wrong cables or they don't have the right nuts and bolts. So all we're saying is make sure that when you're scoping your project, you are thinking it all the way through so that you're not wasting a lot of money on labor, man hours in the field when you're trying to deploy.
So, guys, in summary, what we want to stress is bring in experts early, right? We can help you simplify selection. We reduce that trial and error, the testing, and all that stuff of back and forth of why isn't this working? And we help you improve your system performance, right? We're never going to just choose out of a catalog. We recommend based on the use case and the application that fits your needs. So whether that's, portals, cables, mounts, any of the accessories that we should be addressing before the install starts. That's really where we shine, right? We help our partners as a value-added distributor scope in the project, the antenna, the read zone. What's our deployment strategy? How do we make the installation go as quickly and easily as possible? Support the hardware together and also set you up for long-term success. So with that, I think we are going into our questions and comments phase. If you guys can type it in the chat, we'd appreciate it. I think we already had some come through, correct, Bethany?
Yeah,
Correct.
we've got a bunch. We've got a bunch. You know what, Bethany, if I may, I'll grab a couple.
Yeah,
Uh,
go for it.
Start from the top. So, couple that I saw that I definitely wanted to address, but someone asked how that forklift antenna was being used. In this particular case, what was happening was customer was just trying to verify that product was in their warehouse. So you got a couple different ways you could do this. You could have people walking the aisles with handheld scanners. You could have We now have seen RFID robots that are kind of let loose during the workday or after hours to roam the aisles just to read what's in the warehouse. They're not really trying to determine exactly where it is. They just want to make sure they still have it. In this case, what the forklift was doing was customer had multiple RFID antennas mounted on a forklift so that on all of the forklifts within their warehouse, so that as those forklifts were deployed throughout the day, they were just reading real time just to verify that particular inventory was in the building. So the answer to that question, how was that antenna being utilized? It was just to do a general read of what inventory was in the aisle. We've also seen the same similar type of situation where we've got antennas mounted on forklifts, but those are mid-range antennas just to read the tag that's on the forks, not to read any other tags in the building, but just to read the tags on the forks, which are 5, 6 feet away. So we've seen them antennas mounted on forklifts being used in a couple different scenarios. One of the other questions that was posed was any particular challenges in a medical environment. So what we see, I don't know exactly which, if you're talking about in an operating room or in a hospital hallway, but I'm going to just speak about medical in general, kind of leads me to the food space as well, where having a clean environment is important. So most of the antennas that are in the market today are just IP54 rated, which means they can get wet, but they're really not made to be washed down. And in some medical spaces, like an OR or a food processing plant, everything's got to get washed down, and there could be no chance of a bacterial buildup. So in those cases, you got to make sure that you're using antennas that meet not just an IP67, but an IP68 or IP69 or IP69K rating, which means that these antennas can be washed down with a chemical solution, or they can be washed down with a high pressure wash. That's not easy to find. We've got, 100 antennas in our portfolio, but there's probably 2 or 3 that meet those specifications. So there certainly are unique challenges in the medical space, but we're prepared to address them with a limited selection of antennas that would be appropriate. Another question that had come up earlier in the presentation when Brendan showed the ATR 7000 overhead solution, the question was, do you use overhead or door portals or both? Typically, what we see is either or at the dock door. So we see more and more people trying to get away from portals and just drop ATR 7000s over each dock door, just because it's typically an easier installation, but also because if it works, then we see people deploying further out into the warehouse to do real-time inventory management. So the answer is typically we see either or, but where integrators are leading with an overhead solution, at the dock door, it's typically because if it's successful, they want to work further out into the warehouse. Um, I have a question here about what type of antenna is in the mat. The answer to that question is that mat in particular is a circularly polarized antenna. Um, it's approximately like a 1 foot by 2 foot panel antenna, but it is designed to have a bigger weight load capacity than your general purpose antenna. And then they just integrate it into the rubber mat. That can be customized, by the way. So if that's something of interest to anyone, please reach out to us directly. Those antennas were originally designed for race timing, like 5 or 10 Ks, but they've moved into the industrial space. Um, Brendan, I've got Ernesto on the chat asking about antennas for shelving. I know we showed a mid-range antenna for shelving, but
Correct.
how do you prevent bleed over when you're in such a small space? Any suggestions?
So really, Ernesto, how you do that right is first of all, we're going to look at the hardware that's going to be selected. So what we chose for that was our RF Max 6x6 mid-range. You are going to have a defined read zone. When you say bleed over, I don't know if you mean shelf to shelf, right? So that's where the hardware selection comes first, the capability of the antenna. After that point, you would be looking at, do we need to tune this? Do we need to filter this? Do we need to set read strength parameters on the reader? Do we need to tune the power down or up? Right. So the hardware is going to be the first choice is that we have a mid-range antenna with this size, with this gain. And as a result, we have a pretty good idea of the zone that we are going to read. After that, that's where tuning and attenuation would come into play.
Right. What else? I just want to see. Got anything else here? Where can I learn more about integrating radar for detecting directionality into the portals?
We, we, we have our contact information at the end of this presentation. We'll have my email and my cell number. Please feel free to reach out. I'm more than happy to speak to you about that. We can learn about your application. Does it make sense to use just the radar or do you need the portals? That's something I'm more than happy to speak about and take it offline. But you will have my contact information after this. Just reach out to me. I'm happy to speak about it.
I mean, obviously we got a couple more, but I think
Yeah.
we'll do one more. I'm looking at one that says, and I don't know if you've got some thoughts on this, Brendan. What are the challenges? So I think this goes back to our slide about it gets complicated. This is where
Mhm.
you had a bunch of different antennas and emergency exit door. What are the challenges when trying to hide system components to make the system less conspicuous? Would putting this in some type of radome impact performance? You want to get your thoughts on that, Brendan, and I'll weigh in.
Yeah, so we actually have again, I was just at Modex, a great partner of ours was speaking specifically about this. Any type of enclosure, right? Metal is going to be an issue. We don't want to enclose with metal, but there are ways, we've seen fabricated boxes that are polymers or plastics that cover up the antennas. Um, it's clearly that custom arch kit that I showed you is not going to be an option, right? If you're concerned about the aesthetic value and making it a bit less visible, that bright yellow arch isn't going to do any favors. But there are a myriad of different ways. I've seen ceiling tile antennas, as crazy as that sounds, where you look up in an office building, it looks just like a ceiling tile, but it's actually reading. You can fabricate boxes, as one of our partners is doing for a very large project, to hide that, hide the wiring, hide the cabling, hide the antenna. So it's often ancillary products that can do that. If you have, of course, a 10 by 10 patch antenna mounted off a wall, it's pretty obvious what's going on. But there are ways to have it in the ceiling. There's ways to cover it or mask it a little bit. And often that's not even just for the conspicuousness of it. It's for an aesthetic value. We see that a lot in retail, hospitality, medical. Mike, I don't know if you have any thoughts on that.
I've seen people build false walls in front of a real wall and have their
Yep.
antennas behind it. And if it's, as long as it's like sheetrock, it'll read totally fine. And obviously, there's also some modular solutions where you could build, like, picture like a trade show display that's acrylic or something. You can put antennas behind it and it's going to read right through. So there are ways to do it to be a little less conspicuous for sure. Um, so yeah, there are ways to do it, and as long as you're not using anything metallic or using metallic paint, should not affect performance at all. I have one question here that says, ATR is a special solution. This would be ATR 7000 overhead solutions, steerable arrays with multiple polarizations and unique beam states. Just want to confirm is just wanted to confirm is Arcadian guiding choice of ATRs with poles versus the use case example. I just want to be clear, we don't carry any overhead solutions, nor do we promote one over the other. Zebra's got their ATR 7000. RF Controls is another company that makes a directionality based overhead system. There's certainly people in the retail space. Zebra's got their smart lens. A company called Radar has a product. A company called Pervase ID has a solution. All we are doing is providing the overhead mounting pole accessory for those and not the actual overhead unit itself. Let's see. I think we can end on this one. Is there any tools that you have to suggest exact hardware, consumables, and layout design based on a particular application or use case? I'm going to say we don't have any kind of a parametric search. Brendan, any thoughts on how you would so
Honestly, the tool is kind of us. That's my first reaction, right? Is come to us. What we can do is we can help with the antennas. What we'll work to understand your project. What's the goals? What's the requirements? And at that point, if you're an end user, we would help integrate you with a partner of ours. If you're a partner, we would work alongside you, right? So the first step is, discovery. What are we working on? What are the hangouts? What's the problem that needs to be fixed? What's the environment? Things of that nature. In terms of just a tool that you can go and flip in, hey, I need X, Y, and Z, and have something pop out. We don't currently have that. It's something we can, discuss. But what I'd really encourage you is to reach out to us early, and we can have those conversations and guide you towards the correct hardware.
I think that's it, unless I'm missing any questions. Listen, at the end of the day, as we know, there's multiple critical components to a successful deployment. There's antennas, that's what we're talking about, but you got to make sure you have the right reader, you got to have the right tags. Software is of paramount importance these days. We've, we're dealing with probably 80 at Arcadian, probably 80 different system integrators. They all have their own expertise, and many of them have their own software packages that are uniquely adept at addressing a particular use case. So what we're finding more and more is a lot of our RFID system integrators are working with one another. The firm that gets the deal might be using a different firm's software. I think it is critical to find the right partner, not only on the hardware side, but on the software side. And we are here as a resource because we know all the partners in the ecosystem and what they have to offer, both from a hardware and deployment services standpoint, but also we know their software packages that they have to offer. So please don't hesitate, even though we don't sell software, but to ask us for recommendations. We'd love to help point you in the right direction. And in addition, if anyone out there is not an integrator, but is looking for a good integrator, again, we have dozens of great RFID system integrators that we work with, and we're happy to point you in the right direction depending on the use case that you're up against. I think that's it.
So, guys, again, thank you for joining us. We really do appreciate your time. On the left, you will see both myself and Mike's emails. That is my direct line. I encourage you, please reach out if you have any questions, whether that's just about, this presentation, questions maybe that pop up later, or if you do have projects and you're looking for expertise to help you kind of move that forward. That's exactly what we're here for. We're here to help.
Yeah. Thank you, everybody, for your time. And for many of you out in the audience, I'm sure I have to thank you for your business. I don't know exactly who's out there, but I'm sure we've got some customers out there. So
Thank you, guys.